On the 8th grade section 8.1, we're dealing with functions. So why are functions important? Well, for example, let's say your school wants to have a bake sale and raise money. Well, the number of baked goods is represented above, so that's how many items you sell. The bottom is how much money is earned from the baked goods. So you have to subtract how much it costs to make the cookie. So that means if I sold 20 baked items, I would make a $10 profit. 30 is $15. Now, the independent variable depends on the independent variable are values that don't depend on the other variable. So that means I'm going to sell baked goods no matter what. Okay? But how much I make, the money I make, is directly related to the number of items I sell, right? So what that means is basically the dependent variable is the one that depends on the other. Okay, I can't have these values unless I have the top values. This is called the dependent variable. It depends. So basically, if I sell no goods, I make no money. Okay? No goods means no money. So the first one is asking us to find the pattern and complete the table. Now, it would be easier for us to say that I would make a $5 increase for every 10. But if I sell 20 baked goods and I get $10 profit, that doesn't go by fives. Okay? So I could add 5, but what I don't want to focus on this pattern and then this pattern, like this is going by 10s and this is going by 5s. There are certain tables that you're going to do that, but what I want you to do is focus on the relation between the two. So 10, I make half the profit of the baked goods, right? I sold 20 baked goods, I make $10. I sold 30, I make half in profit, $15. So if I want to continue this pattern, half of 40 would be 20. Half of 50 would be 25. Half of 60 would be 30. Okay, so it's 20, 25, 30. Now, I could go by fives, and it would be easy to know that 70, right, if I go one more up, if I had 70 here, then I just add one more 5, which is 35. But, or half of 70 is 35. So if I sold 70, it would get me $35. But this pattern of having it half will help us with the 100. If I sold 100 baked goods, well, instead of me having to add every time another 5, I'm going to say half of 100 is $50. Okay? So, go ahead and write this down. We have several boards for this one because I wanted you to understand 8.1. So pause it, write it down, and we're going to go to the next board. Each element, a function. Each element of the domain, a domain is input independent, which is my x value, is paired with exactly one element of the range, which is your output, your dependent, okay? So the domain would be the number of baked goods from our other example. The range would be how much profit you make, because it's the one that depends on the domain. This is my y value. So I can have a function as long as if I have an equation y equals mx plus b, okay, let's use this example question, y equals, if I have an equation that fits the line, okay? This equation. If it's a function, well, this is always a function, so I have an equation, okay, something here, y equals something. If I have an equation and I plug this equation in, okay, an example, I plug 1 into this equation, it should spit out a number, y, right? I plug another x into this equation, it spits out another number, y. Okay, so this is called a one-to-one. It's represented. For each value of number I put in, it spits out an exactly one y. So this is in fact a function. But if I have a function and I put in a 1 for x, y equals x plus 3 or something like that, okay? If I put in a 1 for x, it gives me 2. But if I put in a 1 again, it gives me 3. It shouldn't be like that. I shouldn't be able to put in a number, do the math, and get one value. And then if I do it again, do the math and get another value. Okay? I shouldn't have two results for the same input. Okay? So this is not a function. Because for the same x, I get different y's. Okay? Same x value, I get different y value. Okay? But I can put a number in and work out the math and get a number, but then put a different number and get the same number. It just sometimes the math works out that way. So in this case, even though I have two of the same y's, but since they're the different values of x, I can have this. This is still a function. It's only not a function, so I can have double up in y's, but it's only not in function if I double up in x's, but I have different y's. Okay? In graph form, we do something called the vertical line test. If I create a vertical line anywhere on here, every vertical line should not touch more than 1 point. Well, that one doesn't touch any points. See? So, this one doesn't touch any points either. My apologies. Okay, so this one touches only 1 point. This one touches 1 point. Barely, doesn't touch that one, but it touches that one. But this one touches 2. Because it touches 2 points right here, okay, using the vertical line test, this is not a function. It can only touch 1 point. I mean, one at a time. This one, it touches also 2. You see how it touches 2 times? This is not a function. A line is always a function, by the way. This one, even though it's a U, but it's facing this way, so no matter where I put the vertical line, it only touches the line, it only touches the line 1 time. So this is, in fact, a function. All right? I have one more board, so go ahead and write this down before you do your example problem. Sorry for the fact that the video is long, but write this down and we have one more concept to go over. Pause it and write it down. So, the last concept that we're dealing with is called function notation. Now this is just a fancy way of writing a y. So you're usually, instead of, you use this by saying f of x. And there's a reason why they put it in that notation, okay? And it's to help make for you to understand the value of x. But these are connected together. You cannot divide by x or divide by f to separate them. They're one thing, okay? And they equal y, so the whole thing represents y. So basically, instead of saying y equals 2x plus 3, I'm going to say f of x equals 2x plus 3. They mean the same thing. I'm going to plug in an x and get the value f of x, okay? So the reason why they have this here is they're going to tell you, they're going to give you an equation, f of x equals 14 plus 3x, and then they're going to give you a number in for x. So what that means is, because now x is replaced by 4, I'm going to do the same thing to everything here. Okay? Because this is replaced by 4, it's telling me that I replaced everything here by 4. So basically it's saying solve y equals 2x plus 3 if x equals 4. It's the same thing as saying that, but now they have an easier version by just saying find f of 4. So f of 4 would mean that I'm going to rewrite the exact problem, except instead of x now, okay, I'm going to plug in 4. I don't do anything to solve this, okay? This, I do nothing, okay? Do nothing on this side. This is just telling me what to do. So from here, I'm going to multiply out. 14 plus 3 times 4 is 12. So 14 plus 12 is 26. And this is my answer. So that means f of 4 equals 26. Please don't try to divide by 4 after this or try to separate this. I know I'm getting annoying by emphasizing it, but it happens too many times. I do the same thing here, but instead of replacing it by 4, I'm replacing it by -7. So 14 plus 3 times -7, which gives me 14 plus negative 21. Okay, this plus and negative together gives me 14 minus 21. And then I end up with negative 7. Okay? So go ahead and try page 401, numbers 2, 4, and 6. 401, numbers 2, 4, and 6, and I will see you in class.